Good morning, students. Today class is based on remote sensing technique, remote sensing and GIS and its application in agriculture. First of all, we have to know about the remote sensing and GIS. What is remote sensing? First question come in mind, that what is remote sensing? Remote sensing is very simple and you all are knowing remote sensing. Remote sensing means getting information, gathering information, taking knowledge or acquiring knowledge about the knowledge of any object or any phenomena without actual touching. Here without actual touching is very important, because we in remote sensing, this is the only thing by which remote sensing application is more and more, and in future and nowadays its application increases more and more because of its without actual touching mode. You all are knowing, mostly I can say during your childhood you have played with remote car. That remote car was based on remote sensing technique. Remote is have kept in your hand, car was kept on the floor, and you were handling that car by using that remote. By that remote you can forward that car, that car can be change the direction, means anything you can control through that remote without touching the car. Similarly, nowadays in most of the television nowadays are applying remote sensing technique. In remote in your room, when you are having remote in your hand and TV is kept far in front of you, and you are changing the channel, you are changing the or increasing or reducing the volume. How it is happening? Here remote sensing technique is used. Without actual touching we are using. Photographs. Right now my photographs are going in front of you. How photographs means camera is not touching to me, but my picture, my videograph is going to you. It is capturing. How? All the places remote sensing technique are used. But here one thing is very important, markable, that we are not touching to the object, but electromagnetic wave are used. So that's why we are actually here referring actual touching, means touching with the help of electromagnetic wave that cannot be seen through your naked eye. That's why we are telling without actual touching. Now here remote sensing definition, a brief definition we can see here. Remote sensing, getting information about an object or phenomena without actual touching, or we can say getting information about an object or acquiring knowledge of any object or any phenomena without actual touching. Here electromagnetic wave are using. That's why we are telling without actual touching. Now GIS. What is GIS? GIS is Geographic Information System, which is a framework for gathering, managing and analyzing data. All the data is gathered and that data is analyzed in computer to get an information about any project or about any objective or about any plan which is planned before the what according to the purpose. Now, working principle. Remote sensing have two working principle. One is active, based on active sensor, another is passive sensor. Active sensor, here two example. Here in first, passive sensor, here sun is the source of energy. Here here we can see here, from sun energy is coming, electromagnetic wave is coming and falling on land feature, and after that this land feature, some electromagnetic wave is absorbed, some is scattered and some reflected back to the sensor. Here our satellite is the sensor. So some part of the electromagnetic wave is sensed by satellite, and that electromagnetic wave is recorded at ground station. So here the satellite has not their own electromagnetic wave for the object, but here in second example, electromagnetic wave is coming from here satellite and reaching to the here land resources, and from land resources some electromagnetic waves are absorbed, some scattered and some reflected back, and that reflected electromagnetic wave received by satellite, and that received signal again come to the ground station for the analysis. Here two things is very important. One, that the whatever electromagnetic wave is reaching to the ground, whether from sun or from the satellite, that electromagnetic wave totally is not reflecting. It depends upon the feature of the ground. Some electromagnetic wave reflect partially, 70%, some reflect 20%, some may not reflect. So these are the main character on which remote sensing based, or the principle of remote sensing based. Accordingly, we can analyze this data through GIS software and conclude to the objective. The electromagnetic wave what we are using in remote sensing, that suppose these are the general spectrum of any electromagnetic wave, starting from gamma rays, X rays to the TV and radio wave. Here we cannot use X-ray or gamma ray or in between rays, because that rays are harmful for living organism, for plant and human being, for animal, anything. So we are using only visible and infrared. Mostly infrared and visible range we are using for detecting any object. Here 0.4 to 0.7 micrometer is visible range, which can be further subdivided into we have divided here blue, green, red, only three color, basic color, primary color we can say, but you can divide it in thousands of spectrum, like 0.4 to 0.5 we can further subdivide it in 10 parts, like 0.41 to 0.4 to 0.43, 0.44, 0.45, 0.46, like that up to 0.5, means 10 part you can divide it. If you will increase it, then further it can go up to 3 part of 3 decimal, 0.456, like that, 3 digit after the point. So accordingly we can divide these 0.4 to 0.7 up to thousands of division according to the objective. What are the objective for which we have to analyze which type of objective we have, accordingly we have to analyze. Now near infrared starts from 0.7 micrometer to 1.3 micrometer. After that middle, then far infrared. So that infrared is also used in remote sensing technique. Now what is happening here, we can say the spectral reflectance band. When this spectral reflectance, whatever electromagnetic wave fall on the surface feature, after reflectance some only few parts are reflecting back, few part of electromagnetic wave absorbed, few scattered, only few reflectance. Here I have given reflectance percentage, and here is the wavelength. Clear cut we can see that chlorophyll absorption band, these two are chlorophyll absorption band, means in this here wavelength, this wavelength and this wavelength. On this wavelength reflectance percentage, this is reflectance percentage decrease, and this decrease can be clear cut denoted that this is chlorophyll absorption band. If chlorophyll content will be high, then reflectance percentage in this range will be less. It means vegetation is more. Similarly, here near infrared plateau is there cell structure. If analysis for cell structure, then we will analyze this part. These are the water absorption band. If water bodies is there, soil, waterlogged soil is there, or soil moisture is there, this here and here means nearly 1.4, 1.9 and 2.7. These are the three bands which we are called water absorption band. So we can see by we can conclude that if this absorption band is reflectance percentage is less in this three point, then we can say that water body is there. So by this way we can analyze the data. So many other indices are also developed, like NDVI, RVI. NDVI means normalized difference vegetation indices. That is permutation combination of the rays, visible rays, red wavelength and near infrared wavelength. By this way we can analyze the even a stage of the crop, even the soil situation, whether soil is having salinity, some soil have this barren land, some soil maybe sandy soil. So this can be identified by using various indices that we will discuss in further courses, in advanced courses. Now type of satellite. There are two types of satellite which we are generally having: geostationary satellite and sun-synchronous satellite. Geostationary satellite mainly used for telecommunication purposes, like television or other telecommunication purposes, and sun-synchronous satellite we are using for, this is remote sensing satellite. For agriculture point of view, we are using sun-synchronous satellite. And geostationary satellite is stationary at a particular above the sun, above the earth, at a particular location, means relative motion of that satellite is same as of earth. because Earth is also moving. If we will compare to the other planet, so accordingly, if Earth is moving, that satellite is also moving, but relative motion is same. So if one geostationary satellite will be above the Ranchi or above the Delhi, that satellite will be always above the Ranchi or above the Delhi. This is the general funda of the geostationary satellite. And that satellite, geostationary satellite, normally fixed at 36,000 kilometers far from the Earth's surface. That is used for the telecommunication purposes. And one more satellite, GPS satellite is also there. Most of the GPS satellite are launched nearly 20,000 kilometers. That is not our purpose to study here. Now mainly we have to study about the sun synchronous satellite. Sun synchronous satellite, which is more important for our purpose, for agriculture point of view. Here this satellite is not fixed at a particular place. This satellite is revolving the Earth. If that satellite is revolving, crossing to a particular place, after few hours that satellite will cross at the another place. Means suppose one satellite bandwidth is 900 kilometer. So after second revolution, it will move to 900 kilometer. But some part will be overlapping. Means when 900 kilometer will be finished, then again from that 900, not just before 900, few meter is overlapping. So again 900 meter bandwidth again covering to the Earth. If some and this sun synchronous satellite is launched nearly 900 kilometer. Normally it vary from 300 to 1500 kilometer, but most of the sun synchronous satellite is fixed at 800 to 900 kilometer above the surface of Earth. And by the use of this sun synchronous satellite, we can analyze the changes in the plant system, changes in the ground reality or feature of the soil or vegetation of the soil. If we want to know about the changes in the crop situation, then we can analyze the data of remote sensing satellite of, suppose we are analyzing data of today and compare it again after 1 week, then we can clear cut see the difference in vegetation growth. Or if some insect attack, pest attack will be there, that can also be analyzed by using so many software indices are there, GIS software are there. By using that software or indices, we can assume, we can predict that maybe this problem will be there, or this thing is there on the Earth surface or at a particular place. So this sun synchronous is very much important for agriculture point of view. If waterlogged soil is there, if barren land is there, soil saline soil is there, these things can be very easily identified by using this sun synchronous satellite, by knowing the feature of this satellite. Now these are the photographs of some satellite. Just for you student, you can see how the satellites are moving around the Earth and how capturing the information, getting information from the satellite, and how this information is again recorded at a ground station, and that information, actually that information we are receiving in digital form. That digital information can be analyzed by the help of so many GIS software, particularly ArcGIS in software, ArcInfo, ArcCatalog, ArcMap, ArcView. These are the ArcGIS software. Idrisi is another software. So many software are nowadays, even in India also, so many software our Indian company also made. Even IIT Mumbai recently they developed one software. So by using this software we can analyze this data, but some problem of recording of this data is happening, that should be rectified. Particularly suppose because earth is not plane, it is curve in the nature, so whatever data is recording, that should be corrected and rectified. Some overlapping in the band is also happening, that is also rectified while digital image processing. Now these are the how to get soil information through remote sensing. So first of all we should have satellite map. Satellite map in the form of digital data. Physical map or any other map are required for overlapping this digital map on the satellite map, because what is happening in digital map we cannot see the boundary of your city, boundary of your state or country. These cannot be visible on the satellite map. So we are overlapping our physical map on that satellite map at the time of analysis. Only after that we can say, oh, this is the area of Jharkhand, this is in Jharkhand, this is Ranchi, this is Bihar, this is means different state. So accordingly only you can locate the place and you can assume or you can analyze the information and get the real situation, real view of that location. GIS tool with hardware and software for analysis of these data. Of course GIS software is required. Earlier also I told so many software, GIS software are available. That software, any software as per your purpose, you can you should require it. And then hardware and software, some like digitizer is also required, because physical map is not in digital form. Whatever available in the market, you have to digitize it. So digitizer is essential. Then some other software are also available. Computer is also required. That computer should be fast enough, so that because the data, satellite data having very more data are there, so its analysis, for analysis it should be fast, computer should be fast, so that it can be digitized and processed fast. Then digital image processing, these all things are feed for digital image processing. In digital image processing, what we told earlier, that rectification is essential. Like earth is curved, so that should also be minimized, their error should also be minimized. And if some boundary have to put, so other map is also required. So, map enhancement is also required. So in digital image processing, so many things are we are doing to conclude for any object, any process. Now land degradation process diagnosed by remote sensing and GIS. Yes, finally we have to know what are the land situation, what are the feature vegetation we have to analyze through remote sensing and GIS. So here soil type means saline soil we can analyze very easily, sandy soil, marshy soil, waterlogged soil. These soil can be analyzed. Suppose some forest are there, inside the forest some barren land is there. We cannot see from outside that these barren land are available inside the deep inside the forest. This can be seen only by remote sensing through satellite very easily. So remote sensing technique is easy and cheap also, and nowadays remote sensing technique are using, and even for town planning also remote sensing and GIS technique is using. We are by the help of GIS town planning is going on. We can plan for crop also. For any estate we can plan which crop is, which grain is more essential, how much grain is required. Accordingly we can plan by using this GIS software. And waterlogging, erosion can also be analyzed through remote sensing technique. Soil salinity, alkalinization, acidification, glacial can also be estimated. Forest land can also be estimated through satellite data, remote sensing data. Land topography, if undulation is there, how much undulation is there, it can also be analyzed, and whether that undulation is suitable for crop or for forest land or for grassland, that can also be calculated by remote sensing data. Barren land can also be calculated. So many suppose rocky soil is there, some stony west area, riverine soil area. This means so many, we have written few one, but we can analyze so many things available feature on the surface of earth. So remote sensing is nowadays very much essential for the development of soil and water, and we are using, and its use day by day increasing and increasing. Thank you, students.